Welcome to Educator.com. Today we're going to be discussing multiplication and division techniques for inequalities. The underlying principle is that with an inequality, if both sides of an inequality are multiplied or divided by a positive number, the resulting inequality has the same solution set as the original inequality. Notice this mentions only positive numbers. When we were working with equations, we said, okay, you can multiply or divide both sides by a positive or negative number, and the equation would still be true. Here, for inequalities, it's different. So we're going to handle negative numbers separately. What I'm saying right now applies only to multiplication and division with positive numbers. So if I had some inequality such as 2x plus 1 is greater than 5. And I decided that I wanted to isolate this to the x, then I would go about it like usual. I would use the subtraction principle, and I would subtract 1 from both sides, and that would give me 2x is greater than 4. But to actually isolate this x, I'm going to need to divide, and I am allowed to do that. I can divide both sides by the same number. So I can divide both sides by 2 and end up with x is greater than 2. So I'm allowed to do that, and this right here will have the same solution set as the original inequality. So I needed to divide by a positive number, divided both sides by a positive number, and that is allowable. I could also multiply both sides of an inequality by the same positive number. Now, the situation is different for negative numbers, and this is something that at first you need to really pay attention to and make sure you don't overlook, or you'll end up with the incorrect answer. What this says is that if both sides of an inequality are multiplied or divided by a negative number, and the direction of the inequality is reversed, then the resulting inequality has the same solution set as the original inequality. Notice what this is saying. If you multiply or divide by a negative number, and you want to come up with the same solution set as for the original inequality, you need to reverse the inequality symbol. If you don't do that, you will not have the solution set that you were looking for. Okay, for example, if I have some inequality, 5x is greater than or equal to, negative 5x is greater than or equal to 25. So I have negative 5x is greater than or equal to 25. Now, what I want to do is isolate this x. So I need to divide by a negative 5. So if I divide by a negative 5, negative number, what I'm going to do, as soon as I divide by that negative number, I need to reverse this inequality symbol. I'm not going to go any farther until I do. So this greater than or equal to turns into less than or equal to. So I divided both sides by negative 5. And what I'm going to come up with is that x is less than or equal to negative 5. So the solution set for this inequality is the same as for my original. And it is the same because when I went and divided by a negative number, I immediately reversed my inequality symbol. And if I don't do that, it's not going to hold up. And I did this with division. It's exactly the same concept for multiplication of both sides of an inequality by a negative number. Let's apply these principles to some examples. First, I'm asked to solve 6x is less than negative 30. So in order to isolate the x, I'm going to have to divide by 6. And since that is a positive number, I can just leave my inequality symbol alone. It still remains a less than. So my 6's cancel out, and I end up with x is less than negative 5. And recall that we can write these solutions a few different ways. Here I wrote it as an inequality. I could also write it as I could also graph the answer on the number line. And I have a strict inequality, which tells me that the negative 5, is not included as part of the solution set. It's just those values that are less than negative 5. Set notation would be x such that x is less than negative 5. Okay, just to remind you of the different ways that a solution can be written for an inequality. All right, in my next example, I have y divided by 5 is greater than or equal to 9. So what I need to do is to isolate the y, and I'm going to do that by multiplying both sides by 5. 5 is a positive number, so this doesn't present a problem in terms of having to change the inequality symbol. I simply multiply both sides by 5. My 5's cancel out over here on the left, and I get y is greater than or equal to 45. On the number line, this says equal to, greater than or equal to 45. So I use a solid dot. And I could have also used set notation if I wanted to be more formal. Okay. In the third example, I have negative z divided by 7 is less than negative 9. So when I look at this, I see that in order to isolate the z, what I'm going to need to do is multiply by negative 7. That means, since I'm multiplying by a negative number, as soon as I do that, I've got to reverse the inequality. If I don't reverse the inequality symbol, the solution set that I end up with will not be the solution set for the original inequality. Okay, so I've got negative z divided by 7, and what I want to do is multiply that by a negative 7. Negative z over 7 times negative 7. So instead of less than, I've got greater than. Negative 9 times negative 7. My negative 7's cancel out, giving me z is greater than 63. Now I originally had less than. I reversed it and got greater than, but these two have the same solution set. Okay? So at first, you just need to pay really careful attention. Each time, stop and think when you're multiplying and dividing with an inequality, is this a negative number? And if so, reverse that inequality symbol. Okay, next we're asked to solve negative 20 is greater than or equal to negative 8w. So negative 20 is greater than or equal to negative 8w. So I stop and look at what I have to do. Isolate the w. In order to do that, I need to divide both sides by a negative 8. Since I'm dividing by a negative number, what I need to do is also reverse the inequality symbol. And I don't wait till the end, I don't work it through and then go, oh, I need to reverse it. Because really, as soon as you do that multiplication or division by a negative number, that symbol needs to be reversed. So I have negative 20, and what I'm going to do is divide that by a negative 8. Okay, so once I do that, I need to change this greater than or equal to into less than or equal to. On the other side, I've got negative 8w, and I'm dividing that by a negative 8. So what I come up with on this side is 20 over 8 is less than or equal to w. And I could take that a step farther and simplify it a bit so that I get 5 halves is less than or equal to W. One more thing that I can do is to put the W on the left side. So instead of saying 5 halves is less than or equal to W, what I'm going to say is that W is greater than or equal to 5 halves. And these two are equivalent, but we generally write it with the variable on the left. So this is going to be my final, the way I'm going to write the final solution set. Okay, today on educator.com, we talked about multiplication and division techniques for inequalities. Recalling that you must reverse the inequality symbol whenever you're working with those negative numbers. Okay, see you soon on educator.com.